So hi everyone, how are you guys doing? First of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IT. And on this particular channel, every concept of physics, chemistry, and maths are being taught to you completely in English. Now, this is a series that I host for class 12 students, and the topic that we are discussing right now is ray optics. This is lecture number 4, and today we'll be talking about curved mirrors. Now, before we get started with today's discussion, let me introduce myself for those of you who might not know me yet. Just a second. For those of you who don't know me yet, my name is Rohit Dixit, and I studied mechanical engineering from IIT Delhi. And for almost past 8 years, I've been teaching physics for the IIT JEE Mains and advanced examinations. Now, I myself was All India Rank 447 and All India Rank 1 and 2 in the two stages of the IIT JEE exams that I took. I also qualified the NTC Stage 2 examination, and I was also in the top 1% in the NACP. Now, in my offline, in this experience so far, all my experience had been offline. This is my first online venture, and offline, I've been associated with some of the topmost institutes in the JEE coaching industry, and I have already coached many students to top ranks in the JEE examinations. Okay, so last year had forced all of us to adapt, and with all the lockdown and everything, a lot of students don't know what to do. So this is how you can adapt, and you can also make sure that your studies are going uninterrupted. Get yourself the Unacademy subscription, and this is what this subscription brings to you. This subscription gives you benefits like live classes where you get to interact with your educators on a regular basis. Then you also have live polls and leaderboards in these classrooms. You also have test series and analysis sessions, and of course you have live doubt clearing sessions. So in all Unacademy Plus courses, every fourth session is a live doubt clearing session. So after every 3 teaching sessions, you have one entire session dedicated to your doubts, where you can ask away any problem or any issue that you're facing. It might be about your theory concepts or your problem solving. All right. Now, of course, apart from these benefits, you also get another great chance to study from the topmost educators all across the India, from the comfort and safety of your home with your Unacademy subscription. So these are the benefits that this subscription gives you. So how do you get these benefits, and how do you make sure that your studies are progressing smoothly? So the first step towards that would be to install the Unacademy app. Now, the moment you do that, you unlock for yourself a lot of features. So first of all, you have a lot of free courses that are running on the Unacademy app, which you can access directly after installing the app. Then you have special classes. So special classes are free classes that a lot of teachers take, including myself. So I also have will take usually at least three special classes a week. Okay, so this is another great opportunity for all you guys. So all you need to do for this to attend these also is just to install the app, and then of course you have quizzes. So these are the free features that you can unlock for yourself just after installing the Unacademy app. And to unlock these features, you can use the code RD Live. That is my code. Okay, and you have yourself the access to these free features. Now, this will allow you to get an idea of how your Plus subscription is going to be. Hi Rajesh, how are you? And if you like the experience that you get here, the free classes, and finally, if you decide to get yourself the Plus subscription, then this is how you go about that. You can go to the Plus section of your app, select your goal as IIT and click on that Get Subscription button. Now, when you do that, you'll be redirected to the payment page, where you'll find a box which will say, do you have a code? That is where you can put in this code RD Live. So don't forget to use this code. This is my code. This will give you a 10% off on all your subscriptions. All right. Now, when you realize you can now pick from two kinds of subscriptions, Plus and Iconic. Okay, if you notice the fees of these subscriptions, so these subscriptions come at these costs. So these are the costs for plus subscriptions: 6 month, 12 month, and 24 month. And Iconic comes at these prices. Now, even at these prices, you realize you are getting high quality education, which is very competitively priced compared to your offline setups. Okay, so most of your offline setups would charge you any fees which would be at least 4 to even 10 times in some cases. Okay, so here you're getting the same quality education from the topmost educators at a very competitively priced subscription fees. Now also, when you click on proceed to pay, you will realize that you get to choose from a lot of options of low cost EMIs. That will ensure that you don't feel the burden of these payments. Now, the Plus subscription, already a lot of you know about. Iconic subscription, let's tell you about that a bit. So, the Iconic subscription is something that will give your IIT preparation and it will bring it to the next level. And how does it do that? This is how it does it. It With the Iconic subscription, you are allotted personal coaches, and you these personal coaches will mentor you and guide you personally throughout your JEE journey, and you also get to attend a lot of IIT workshops, receive expert guidelines, get study planners, and have test analysis sessions on a regular basis. So these features will ensure that your studies are not only going smoothly, you are getting more personalized attention, and your JEE preparation is the next level. All right. Now you can also buy combo subscriptions. So if you're looking for a one-stop solution for all your study preparations, be it about boards, be it about JEE, you can go for combo subscriptions. So there are four kinds of combo subscriptions that are available. The first combo subscription gives you the Iconic subscription for IIT JEE studies and a plus subscription for your 11th and 12th CBSE studies. The subscription starts at around roughly 4,700 a month. Then you have a combo where you get all three Iconic subscriptions, and this combo starts at around 5,500 a month. Further, you have just a second. Yeah, further you have a combo where you get all three plus subscriptions. This one starts at 3,000 per month. And finally, you have a plus combo of a plus subscription for IIT and an Iconic subscription for your CBSE 11th and 12th. The subscription starts at 3,900 a month. So with these combo subscriptions, as I said, all your worries of studies are taken care of. So your competitive exams, your boards, every preparation is done. Now, another great way of judging your preparation, testing your standing amongst your peers, and winning yourself some really cool prizes is by taking part in the Unacademy Compact. So the next Unacademy Compact is going to happen live on the 17th of January. You can enroll now in that using the code RD Live and do well and win yourself some really cool prizes. Next, uh, this is the link which you can follow if you want to connect with us on the Telegram app. So if you're following us on the JEE English channel, you can connect with us on the Telegram app using that link. Now that'll ensure that you're getting all the timely notifications of all the lectures and sessions happening on this particular channel of YouTube. All right, with that, let's get started with today's discussion. As I said, this is lecture number 4, and today we'll continue our discussion on curved mirrors. So last time we started our discussion where we define the what kind of mirrors are called curved mirrors. We also talked about there are two kinds of mirrors which we are talking about. So there was concave mirror, there was convex mirror. Then we also defined some important terms about those mirrors, including the focal point, center of curvature, radius of curvature, principal axis, etc. And finally, we realized that if you want to find the image formed by a curved mirror, you can do it by two methods. So you can either do it geometrically by ray tracing. I told you the rules of ray tracing in the last class, or you can apply the mirror formula. Let's talk about the mirror formula one more time. So again, I've shown the derivation of this in the last class. So I will just reiterate the mirror formula. The mirror formula relates the position of the image with the position of the object and the focal length, and it is given by this. Okay, now please remember that this formula can be used for both the mirrors, and here please use this formula with proper signs. Okay, use with proper signs. Okay, so that is very important. Next, you realize f is also related to the radius of curvature like this. This is another important relationship. Okay, that F equals R by 2. And if you remember, F is a negative for concave mirrors. Okay, for concave mirrors, the F is taken as negative, and for convex mirrors, it is taken as positive. Okay. Now, with that information, I had given you one question to practice. Okay, so this is the question that I had given you. Let's see how many of you solved this. Why don't you guys try and tell me the answers? I don't know how many of you tried this, or you can try this right now, and then we'll discuss the solution. So this question is telling you that a concave mirror and a convex mirror are kept facing each other. The focal lengths of the two mirrors have been told to you, the distance between them has been told to you, and an object is kept between these two mirrors. And you have been asked that to find the position of the image formed by after two reflections. Okay, that is what you have to find. Okay, let's see how many of you found this. So I'm just checking if I received any answers in the comments for the last video. No, I did not. Why don't you quickly try this, and let's see. Okay, any attempts right now? Did anyone try this, or you want to try this right now? I mean, if not, then I will go ahead and solve this. Okay, let's see. Let's wait for you guys. Hmm. So I don't think anybody tried this. Okay. So why don't we see how you would have solved this? So you've been told a concave mirror of focal length 10 centimeter and a convex mirror of focal length 15 centimeter are placed facing each other. So let's draw ourselves a situation. Let's say you have a concave mirror like this, and a convex mirror like this have been kept facing each. So this is a concave mirror. So this is the reflecting side. This being the convex mirror. This would be the reflecting. Okay. So now what have you been told? You've been told that they are placed together with their common axis of principal axis coinciding, and the distance between them is 40 centimeters. Okay. So let's draw the common principal axis, and you've been told that the length of this is 40 centimeter. All right. Then you have been told that the focal lengths are as follows. The focal length of the concave mirror was 10 centimeter. That of the convex mirror was 15. So here F is a 10 centimeter, F 15 centimeter. Right. And let's see. Next, you've been told that a point object is kept between the mirrors on their common axis 15 centimeter from the concave mirror. Let's place an object here, somewhere here at a distance of 15 centimeters. This is object. And you have to find the position of the image produced by reflection first at the concave mirror and then at the convex mirror. So let's try and find the position of the image from first after the reflection through the concave mirror. Okay, so for concave mirror, I can say for the first reflection, okay, for the reflection from the concave mirror. For the reflection from the concave mirror, what I can do is I can use the mirror formula and I can say 1 over V equals 1 over V plus 1 over U equals 1 over F. And if I write the values, so I told you if the light is traveling in this direction, okay, for this mirror. So this direction is taken as positive. This will be taken as positive, and this will be taken as negative. So obviously your focal length obviously would be negative, which you already know. So U is minus 15 centimeter and F is a minus 10 centimeter. So let's try and find out the V. That is the location of the first image. You realize 1 over V would be equal to 1 over 15, 1 over 15 minus 1 over 10. That'll give you minus times 5 over 150. So that is minus 1 by 30. So you are getting V as minus 30 centimeter. So which means where does the image form? So the image you realize will be formed. So this will get reflected and this will get reflected. And that is where the image is going to be formed. So let's call the image I1. So you realize I1 is formed here. And this is formed at a distance of 30 from this mirror. Now this image will behave like an object for the new mirror 2. Okay, so this is M1 and this is M2. So when this behaves as an object, now you realize this distance will be 10 centimeter. Okay. So next, that is how I will move ahead from here. I can say now this image, this image acts as an object for M2, right? So let's add a page, carry forward with the solution. Now for the second reflection, what all do I have? So for the second reflection, I have this mirror. And I have I2 behaving as an object, or I1 behaving as an object with this distance in 10 centimeter. So I can see that for the second reflection, for the second reflection, for the second reflection, what is U? Again, now you realize for the second reflection, the light would be traveling in this direction. Okay, light would be traveling in this direction. So obviously that direction would be taken as positive, and this direction would be taken as negative. So what you realize is that for this, U will be minus times 10 centimeter. And if you remember your F, that was given to you as 15, and we will take that as plus 15. F is plus 15 centimeter. Okay, now we will find the image due to this. So you can even judge that from ray tracing. That the image would be formed somewhere here. Okay, this is where you have the final image I2. Okay, and now let's also judge that with the help of this formula. Now applying 1 over V plus 1 over U equals 1 over F. What I realize is that 1 over V would be equal to 1 over 15 plus 1 over 10. Right, so what is that telling me? That is getting me 25 over 150. So that is equal to V equals 6 centimeter. So this is where my final image is going to get formed. Okay. Let's see. Pen stopped working, I guess. We just correct that. So here you have the solution. Okay, ARJ, don't worry, sir. I'm just dropping by to say hello, won't disturb. All right, ARJ, don't worry, it's all right. It's always good to see you in any case. Okay, so this is our answer. So this is our answer. Okay, V equals 6 centimeters. So final image is formed 6 centimeters right of the concave mirror or convex mirror. Okay. And of course, it's a virtual image which you can see. Okay, so that is going to be our answer. Okay, I hope all you guys followed this. This should be easy to see. Okay, all right. Okay, so take a look at this and let me know if there is any confusion. Okay, so our final image is from 6 centimeter to the right of the convex mirror and is virtual. So that is all I can tell you about the image form, position of the final image produced, and what is the nature of it. Okay. Hi Aftab, how are you? Okay. So again, I hope nobody has any issues with this. All right. Now we will talk about lateral magnification. So lateral magnification refers to the size of the image as compared to the size of the object. So here we have shown you one example. So here I have taken that the object is like this here, okay, and the image that is getting formed is formed here. Okay, so this object forms an image at this location, and I want to relate the size of the object with the size of the image. Now, all I need to do is we considered two rays for image formation. Considered one ray which was parallel to the principal axis. Okay, that ray after the reflection would pass through the F. Okay, another ray was considered was the ray which is incident at the pole. Okay, now such a ray after reflection got reflected symmetrically with respect to the pole, right? So now from this figure, what I can tell you is, so if this angle is theta, this angle is also theta. If this angle is 90, this angle is also 90. So if you take a look at these two triangles, so triangle ABC and triangle A dash, ABP and triangle A dash B dash P. So what I can say is from the ray diagram, from the ray diagram, we find that the triangle AB is similar to triangle A dash B dash P. Agreed? So we can see that this angle, two angles are theta and 90 each in these. Okay, so all three angles in fact become equal. So what does this tell me? That tells me that A dash over A dash B dash or A dash B dash over A dash AB will be equal to V over U. Agreed? So that is what the relation between the image size and the object size would be. Okay. So I can say therefore A dash B dash over AB would be equal to B over B dash P over BP. Okay, so that is the relationship that you have. Okay. Hi AP, how are you? Okay. All right. Again, having some. All right. Now you realize that this is telling you the relation between the object size and the image size. with respect to the image distance and the object distance. Now, if you take sines into consideration, if take, take sines into consideration, then what you'll realize is that the size of the image would be in negative, and the size of the object has to be positive because image is formed below the optical axis and the object is above the optical axis, right? So what you realize is magnification M would be equal to minus V over U. V and U both have same signs, okay, but in the ratio I want a negative sign to be there. So this is how I will write this. Okay. So I hope you guys followed that. Okay, so I seem to be having this problem one more time. So that is so weird. Okay, right. So here we have it. Okay. Oh, why there is such a lag in this? All right. This seems to be getting behind. Okay. So again, as I said, the linear magnification, which is the ratio of the size of the object to the size of the image, can finally be written as minus V over U, where V is the image distance and U is the object distance. The minus sign tells you that the object and the image are formed in the opposite sides of the principal axis. Okay, so this is what you have as the final formula. Please remember this. This is very, very important. Okay. So remember that this is important. Okay, now let's move ahead. And now let's talk about the longitudinal magnification. So earlier we were talking about an object which was kept perpendicular to the principal axis. Now what happens if an object is kept along the principal axis? Then the magnification is called the longitudinal magnification. And in this case, what you do is you realize that you talk about this one end, and let's say this has image position, the object position of U1, and the other end has position at U2. Now the image of this one, so let's denote these by two different colors. Let's say the image of this one is obtained here, and the image of this one is obtained here. So now the ratio of the size of the object is to size of the image would be simply, so in such a case, so we will say in such cases where object is placed along the principal axis, what you realize is that we find the image points or the image locations of the two ends of the object. Okay, and finally your magnification M dash would be equal to V2 minus V1 over U2 minus U1. Okay, with mod signs, of course. So this is how you talk about this kind of longitudinal magnification. Okay, so longitudinal magnification is defined for objects placed along the principal axis, and lateral magnification is defined for objects which are placed perpendicular to the principal axis. Okay, all right. So now that you know how to calculate this, also now let's talk about superficial magnification. So if you have a 2D object, if a 2D object is placed in its plane perpendicular to the principal axis, then its magnification is known as superficial magnification. So imagine this is what an object is. So what you can say is that if this is the size of the object, so if this is some a by b, then you realize this is a lateral magnification. Okay, so here this size would be a times m, and similarly this times would be b times m. Okay, so both these sides would get literally magnified. Okay, so I can say for a 2D object, is as shown. Both sides, both sides get literally magnified by a factor of m. Now, therefore, what you can say is superficial magnification. Therefore, superficial magnification becomes equal to m square. Okay. So that is what I was trying to imply. Since both the sides become m times, so the total area will become m square times. So superficial magnification is m squared, which is essentially square of the literal magnification. Okay. Now, instead of this, imagine if the object was kept like this. If the object was kept along the principal axis, then what happens? Then you realize if this side was A, if this side was A, then this side would be M times A. And how about that side? That side, again, the entire shape would have gotten distorted. The entire shape would have gotten distorted. You don't even know how the image form will be. Okay, so yes. So turns out the image may be of the form of like this. That is the kind of image that you may have had. Okay. 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 Now I hope I'm not going to have any more disturbance. So this is the kind of image that you would have seen. And in that case, to find out the magnification, what you would have done is you would have found the area. Okay, and this side, let's say, would have been some m1 times a, and similarly, if this was b, if this was b, then this would have been some m2 times b. Okay, and then you would have found these two locations also. Okay, so yeah, that would have been much more complicated to figure out. Okay, but this is how you would have found it. Okay, you realize if this was u1, this was u2, this was v1, this was v2, then what the thing would have been the opposite way. Would have been u v1, and this would have been v2. What you would have had is that m1 times a would have been here. This would have been m1 times a, and this would have been m2 times b. So this is how you would have gotten your image. Okay, and then you could have told about this image, but that would be a really complex problem. That is something that IIT JEE Advanced would have asked you. Okay, so again, in such a case, What you do is break the problem into two parts. Okay, first find the image of this, which is found here. Then find the image of this end, which is formed here, and then join the two with straight lines. So finally, when you have the two images, then you can talk about the size of the image and its expansion and its magnification and so on. Okay. All right. Now that we have discussed all these points, now let's try and solve some problems. Okay. So this is the first problem that I want you guys to try. The focal length of a concave mirror is 30 centimeter. You find the position of the object in front of the mirror so that the image is three times the size of the object. Okay. So what information have you been told? You have been told the focal length. Okay. Next, what you're being told is position of the object in front of the mirror so that the image is three times the size of the object. Okay. So try this. Try this. Let's see. Let's see if you can figure this out. Okay. So here, please remember you'll have to consider two cases. Because if the image is to be formed which has a three times size of the object, there can be two kinds of images. Okay, remember, virtual images also formed are magnified by concave glass, concave mirrors, right? So you can have two kinds of image object distances. Okay, one where a virtual image is formed, which is of three times the size of the object, and one where a real image is formed, which is three times the size of the object. Because it doesn't say what kind of image is to be formed. It just says the image size should be three times the size of the object. Okay, so let's try and solve this. Okay. So again, what you will realize is that what you have to do is let's solve this because this is the first problem. So I'm going to show you how to solve this. So you have been told f is 30. F will be taking as minus 30 centimeter. U I don't know and V I don't know. M is 3, so that can be plus minus 3. Okay. So I will solve under two cases. Case 1, image formed is CL. So in that case, M would be equal to minus 3. So I can say V equals minus 3 2. Correct? So now what I can do is therefore 1 by V plus 1 by U equals 1 by F, and that would have given me minus 1 by 3U plus 1 by U equals 1 over F. So that gives me minus U plus 3U over 3U square equals 1 over F. That gives me, I have yeah. So I would have had U equals 3U by 2 equals F, or 2 equals 2 by 3F, which would have given me 20 centimeter, minus 20 centimeter. That is my answer number one. Okay, I hope you guys followed this. तो पुष्पल पॉल से सर सिलेबस कब तक खत्म होगा? सिलेबस यार लेट्स से अभी ऑप्टिक्स चल रहा है, इसके बाद मॉडर्न और बचता है, सो मैक्सिमम बाय नेक्स्ट मंथ के सिलेबस खत्म हो जाना चाहिए। इस मंथ में ऑप्टिक्स हो जाएगा और फिर बस मॉडर्न बचता है आपका। ओके, मॉडर्न आपका नेक्स्ट मंथ तक मैक्सिमम खत्म हो जाएगा। ओके पुष्पल, so this is how you would have found the answer for you. That is the first answer. Now you could have had another case where the image formed was virtual. Okay, in virtual case also you should remember that magnified images are formed, right? So now let's consider case number two, where the image formed is actually virtual. Okay, let's talk about that. Okay, case two, image formed is virtual. So in that case, M would be plus A instead of minus. M would have been plus because the image form would be erect, right? So therefore, you would have written V equals plus 3U. So therefore, you would have had 1 over V plus 1 over U, which would have given you 1 over F. Your realized phase would have been 1 over 3U plus over U equals 1 over F. So that would have given you 3U over 4 equals F, and hence 2 would have been 4 by 3F. Yes. U should be less than F, no, for virtual image to be found. Mhm. Yep. This is what I'm getting as my answer. Hello, Dhruv, how are you? Yeah, I know. It is coming out to be 40, minus 40 centimeter. But I was just wondering for the virtual image, I don't know if we have calculated something wrong. For the virtual image, the U should be less than F, right? U should have been less than F. I don't know. That is the only confusion that I have. One is 40, one is 20. So I think we have taken the other way around. Oh yeah. Okay. Right. So yeah, we have considered the two cases. One in which the image is lying before F, and one where it is lying beyond F. All right. So we have got both the cases. So in the first one, yes, we did get it as 20, and the second one we did get it at 40. So yes, these are the two answers. Great. All right. So this is how you would have solved this. Hi Dhruv, how are you? So why don't we start with another practice problem? So which class are you in, Dhruv? Which class are you in, Dhruv? Okay. All right. So let's try this problem again. Let's try this problem. Okay. Oh yeah. Now I remember what I did. Ah, the signs I took were opposite. Right. If it was real, then I would have gotten this because M was minus V by U. Was minus V by. That is why. That is why I'm getting the opposite. For virtual would be this. Okay. Yeah. All right. Now let's talk about this question. This question tells you that a thin rod of length f by 3 is placed along the principal axis of a concave mirror of focal length f such that its image, which is real and elongated, just touches the rod. What will be the magnification? What will be the magnification? Okay, so this should be interesting. Try and solve this. Okay. So you have an object which is kept along the length like this, right? So you've been told that the length is f by 3 and the image is real, elongated, and just touches the rod. So what does this information tell you? What does this information tell you? Hmm. So this information tells me that if this was the convex concave mirror, and if this was the principal axis, then if I have the elongated object kept like this, now for the image to just touch this, what you realize is that this end, so let's give these two ends some names. Let's call this end A and let's call this end B. So since the image just touches this, so the image should be like this. You would have had A dash form somewhere here, and you would have had B dash form somewhere here. So obviously B has to be at the center of curvature. Okay, so what score do you think I should aim for now, sir, for Feb? Since you know how I prepared. Okay, yeah, Jay. So I think you should definitely try for around 60% at least. Okay. So you have told me that you have problems with your 11th syllabus. Okay. So let's say you have only 75% of the syllabus prepared, right? Let's assume if you have 75% syllabus prepared, then you should try to aim at around 80% of this. Okay, so roughly 80% of this would be roughly 60%, right? 60% is what you should target. 60% marks. Okay. I hope that helps you, Arjun. Okay. So from the given information, what we realize is that B and the B of the rod must be at the center of curvature. That is why the image of B dash is being formed right there. Okay. Now that I know that, I know what is the distance of object A. So since this entire thing would be 2f, this is f by 3. So this I know would be 2f minus f by 3, right? 180. So this time I think they are going to have the paper for 300 marks. So yes, 180 is what you should be trying. Okay, and 180 is a pretty good score. Pretty good score. If you manage to get 180, trust me, you will be getting a rank in top 15,000 to 20,000 at least. Okay, but again, you'll have to work very hard for that also. You will have to work very hard for that. Okay, so let's talk about the solution from the given data. Okay, from the given data, we conclude that end B of the rod must be at C. Okay. So we realize that end B of the rod must be at C, where C is the center of curvature, right? This is the center of curvature. Now that makes the position for A as, so therefore for end A, how much will U be? U would have been 2f minus f by 3, right? I just showed you. This comes out to be 5 by 3 f. Okay. Now, once I know the object position of end A, I can find the image corresponding to end A. Okay. Therefore, position of A dash is V can be found using mirror formula. So let's talk about this. 1 over V equals 1 over V plus 1 over U equals 1 over f. So what is the focal length? Focal length is f only, okay. So what I can say is 1 over v equals 1 over f minus 3 over 5. 1 over v equals what you would have gotten is 5, 2, 2, so 2 by 5. F v is coming out to be 5 by 2f. Okay. So the image size would be f by 2. Hi VVK, how are you? Therefore, length A dash B dash equals 2.5f minus 2f, so that is 2f. Okay, so what is the magnification? So this was f by 3, this is 2f. Therefore, magnification would be 2f over f by 3, so 6. So image has a magnification of 6. Okay, I hope you can realize that from the given data, so whatever data has been given to you, from that I can conclude that the end B of the rod must be at C. If the end B was at C, then I can find the position corresponding to the A. Okay, and once I do that, then I can find the position corresponding to A dash. Once I find A dash, now I can find the image. Okay, so wait. I just realized this is f by 2. 0.5f, not magnification will be 1.5, not 6. F by 2 over 5. Magnification is 1.5. Okay, so this is how you would have approached the problem. You figured out the location of end B. You would have found the position of point A and found the corresponding position of A dash. Once you have A dash and B dash, you would have found the thickness of that image, right? Once you have the length of the image over the length of the object, that would have given you the magnification. Okay, the magnification is 1.5. The image is 1.5 times larger than the object. Okay. Now, please note here I haven't put any signs. Why? Because I have already assumed that all the signs are included in the value of f. Okay, or in the value of f, the f already has a sign along with it. Okay, that is why I'm getting everything in terms of f, and f already has a negative sign, so every value has a negative sign inherently. Now, that is what I have assumed. All right. Now let's try another tricky kind of a problem. So this problem says that sun subtends an angle theta radians at the pole of a concave mirror of focal length f. Then what is the diameter of the image of the sun formed by the mirror? Okay, that is what you have to find. Okay, let's see if you can find this. You have to find the image, diameter of the image of the sun. Okay, let's see how you can do this. Okay, so anyone trying this? How do you think you could have gone for this? Please note that whenever you try to find the image, okay, you do that. So let's talk about this. So here is your concave, uh, and imagine here was your sun at infinity. Sun was here at infinity. Now, if this was the sun, then what you realize is that it's draw the principal axis. So the upper end of the sun, would have formed. This is how you do it. So what you realize is that if this angle is theta, if this angle is, let's say, alpha, then this angle is also alpha, and you realize the size of the image can be obtained on related to f. Okay, so to alpha, how? If you know this v, then what you can say is when image it is formed at with an angle alpha. Now, what I can do is, if I have to find the size of the image, okay, let's say that is I, okay, then what I can say is sine of alpha or tan of alpha rather, in this triangle. Ah, so focus on this triangle, okay. So this is, let's say, A, this is B, then this is B dash, this is A dash, and this whole P. So in the triangle A dash B dash P, in triangle A dash B dash P, what you can say is tan alpha equals A dash B dash over V. And since we only talk about paraxial rays, since all rays are paraxial, right? So I can say alpha tends to 0. Therefore, tan alpha would be roughly equal to alpha. Therefore, A dash B dash would be roughly equal to alpha times, right? So that is our idea that we are going to find here. Okay, in this particular case, okay, in the case given, since I can say U is infinity, so what is V? V will be equal to F. So therefore, diameter of image of sun. So you realize the radius would be given by half angle into this, and the diameter would be given as theta times. As simple as that. I hope you guys followed this. Okay, so that's the logic that we are using. So you can take a look at this ray diagram again, and what you can say is that this is d by 2. If this was d by 2, okay, let's call that capital D by 2. Capital D by 2, and this was equal to small d by 2, and this would have been theta by 2, and this would have been theta by 2 again. Why? That is why the total angle subtended, because of the symmetry. Because of the symmetry, you will realize that the total angle subtended by the sun would have been theta. Okay. If that angle was making, if that ray was making an angle with the pole of theta by 2, then it would, when you go back by theta by 2, you would have reached this end. So the total angle subtended by the sun would be theta. So in that case, you will realize here alpha would be equal to theta by 2. So you would have said that d by 2 equals f times theta by 2, or d equals f times theta. Okay, I hope that is clear. Right. Now let's talk about the velocity of the image when object is moving. So in case number 1, we consider the velocity component along the axis. So case 1, object is moving along the principal axis. So let's try to relate the image and the object velocities. So if your object is moving, let's say you have your mirror here, okay, and you have your optical axis like this, and let's say you have any object and it is moving towards the mirror with some speed, v of object. And what you realize is that at any certain instant, if this is a u, so let's say, so at if at a certain instant, at a certain instant, the object is at a distance u away from the mirror, and you realize let the image be at a distance c, right? And image be image at a distance c, at a distance c, then you know that 1 by v equals 1 by v plus 1 by u equals 1 over f. So if I differentiate these expressions on both the sides with respect to time, what I get is therefore minus 1 by v square, okay, dv over dt minus 1 by u square du over dt equals 0. So what I can realize is that dv over dt, which is the velocity of the image, is equal to minus v square over u square du over dt. So I can say that velocity of image is minus m square times velocity of object. This is important. Okay, this is how the image velocity would be related. Now the minus sign is telling you that if your object is going in this direction, then your image will be going in the opposite direction. I. This is the image I. Okay. So if object is moving towards the principal axis, towards the pole, then the image will be moving away from the pole and vice versa. That is why you have the negative sign. And if you can find the instantaneous m, then you can find the instantaneous velocity. Okay, this is the instantaneous velocity, by the way. Okay, now we'll consider case number two. Case number two, if the object is moving perpendicular to the principal axis. So imagine here is your mirror again. Here is your principal axis. And imagine the object is somewhere here. Okay. Along such a line, and your object is moving like this with a velocity of O. Okay. Now what you realize is that since u is fixed, so the v obviously will be fixed, right? U is not changing, so the v will also not change. So what you will realize is that v would be somewhere here, and image would actually be moving in the opposite direction like this. Okay. And now what you can see is that if this is a distance x, so if this is a distance, let's say of y, and if this is a distance of y dash, so what I can say is I know. So if object is moving perpendicular to the principal axis, now what you will realize is that I already know what is the ratio of y is to y dash. I know y dash is to y equals minus times v over u. Correct? So what I can say is dy dash by dt would be equal to minus v over u times dy over dt. What I realize is velocity of image is m times velocity of object. So here it is m times, and there it was minus m square times. Okay, right? I hope that is clear. Now you realize if you have any general case, then you can find the two components of the velocities and find the final velocity of the object. Okay. Now for a general case, break the velocity vector, the VO vector, two components. Which two components? Parallel to the principal axis and perpendicular to it. And find the corresponding VI component. Okay, so once you have broken a VO in these two, so let's imagine what I'm trying to say is that if in general you were told that this is your mirror, this is your axis, and here was an object which was moving with some velocity vector which is directed in some random direction, VO. So what I would have done is I would have broken this VO into two components. I would have found this component, I would have found this component. Then I would have found the corresponding velocity components for the image and finally reported the velocity of the image as the vector sum of these two. Okay. I hope that is clear. Okay. Now we will talk about another term which is called power of a mirror. Now, power of a mirror is defined as the reciprocal of its focal length in meters. Please note. So what is essentially power of a mirror? Power of a mirror is basically telling you the converging ability. It is telling you the converging ability of a mirror. Okay. So let's write about that. He denotes or measures the converging ability of a mirror. Okay, so smaller is the f, the higher is the converging power, right, of the mirror for parallel rays. I mean, imagine. So if you had parallel rays coming to the mirror, and if they could get converged far away, you would say that the converging power is slightly low, and if it could converge very near the mirror, then you would say that it is trying to converge them very fast, right? So that is why power is defined as 1 over f. 1 over f, the smaller the f, the stronger you say is the converging power of the mirror. Okay, so this is how you define it. And when you define it like this, the units are diopters. Okay, or denoted with capital D. That is the SI unit, diopter. Now, we will also talk about Newton's formula. Now, in case of spherical mirrors, if object distance is x1 and the image distance is x2, and these are measured from the focus instead of from the poles. Now, we usually traditionally measure u and v from the poles. Now, instead of that, if I measure both these distances from the focus, so as shown here. So, if here is your object and its distance from the focus is x1, and here is your image, and let's say the distance of the image from the focus is x2. Then if I write a relation between x1, x2 and f, what I will get is, I will realize that then the distance of the object from the pole is f plus x1 and that of the image is x plus x2. Using this into the mirror formula, I get a relation between x1 and x2 and f. So which is x1 x2 equals f square. Now this is known as the Newton's formula. This is important. This formula was given by Newton. Newton's formula relates the focal length of the mirror with the distance of the object and the distance of the image from the focus. Okay, so this is known as Newton's formula. This can be used directly to solve questions at times where all the distances have been given from the focal point. Okay, so remember this. All right. Now that is all the discussion that I had planned for the day. Okay. Now before I leave, I think we still have time, so maybe I can squeeze in one more topic. One more topic. So we know that one very important property of these mirrors was to be able to focus the light, parallel light incident on them. Right. However, what we realize is that they cannot do a very good job at focusing light. So they have some errors because of these. I can tell you about errors related to that is one thing that we did not talk about. Errors related to mirrors, spherical mirrors. Now the problem with spherical mirrors was that all the consideration that we are taking is under the assumption that all rays are paraxial. If the rays are not paraxial, then all these mirrors show something called spherical aberration. Spherical aberration. Okay. That is inability of these mirrors to focus marginal rays to a single point. So if I wanted to focus marginal rays, then I have a problem. So if marginal rays were allowed to fall on a spherical mirror, you would have gotten a blurred image. Okay. Thus, if marginal rays, marginal rays were allowed to fall on a spherical mirror, the image obtained would be blurred. Now that is what you call spherical aberration. Okay. That is what you call spherical aberration. Now, how do you remove this spherical aberration? So, to remove this defect, we can use parabolic mirror. Okay, so using parabolic mirrors can actually focus the light truly. And let's see how it happens. How does that happen? Let me add on the page and prove to you. Imagine. So I'm trying to figure out the equation of the mirror for which can focus all the light incident on it to a single point. So aim is to find the equation of a mirror that can focus all the light incident on it to a single point. Okay, so let's imagine that is our aim. Okay, and let's say that I have a pole which obviously I take as the origin. Okay, so we get ourselves two axes. Okay, we are keeping the pole as the origin, and I'm assuming that parallel rays are coming and falling on the surface of this mirror. So this is my pole. This is what I'm treating as 0, comma 0. And let's imagine that this is some random point of the mirror which is having coordinates of x, comma y. So what I want is when a light ray falls on this, imagine a light ray moving parallel to the principal axis. When it falls on this, it should pass through point. And imagine if the light ray is coming like this and it is getting reflected, it also passes through this F. Okay, so I have found my F, which is the focal point, okay, here. Now, I'm assuming that a light falling on the pole directly gets reflected, and any ray parallel to the principal axis incident at any random point of the mirror, which has the coordinates of x, comma y, also after reflection passes through F. Now, if I can find a generalized point for which this will always happen, then I can find myself the equation for the mirror. Okay, so I can say if light incident on any given point, then x, comma y of the mirror passes through F, passes F after reflection. Then I can conclude that all the rays after reflection will focus on F, because I'm taking any general point x, comma y. For any general point, if the ray after reflection passes through F, then all such rays will pass through F. The ray optics versus thermo, both are equally big. Which one is better? Okay, so I think both are very important. You shouldn't leave out on both. Okay, both are important. Don't leave either of such topics. Okay. Yeah. Through F after reflection, then all incident light will get focused there. Okay, I hope that is clear to you. Yeah, I got it, but I don't think you should be leaving out on any of these topics. Okay. Now I know I told you. Now remember Fermat's principle. Fermat's principle says that if a light ray is supposed to take a path originating from infinity and going to F, then it will always take the path of shortest time. So if it has to take the path of shortest time, here are two paths that are available. So this is path number one, this is path number two. Okay. Now, if two shortest paths are available, that would easily imply that the path lengths of both the paths must be equal. Okay. Do you agree? You agree that this would simply imply. So I can say now, according to Fermat's principle, path lengths of both paths one and two should be equal. See, if that is the case, then I can say that any light ray originating from infinity, if it has to go to F after getting reflected from this mirror, can either take path one or take path two. Both are the paths of least time. Okay. Now, what I will realize now is that Up to here, the path lengths were similar in any case. Okay, so up to here rather. Sorry, up to here the path lengths were similar in any case. Okay, so up to this point, up to reflection, both from infinity had covered equal paths. Now the extra path that both are covering from here on. So from here on, what is the path covered by this ray? Let's give them some colors. So this ray is covering this path, and this second ray is going to cover this path. It is going like this and then coming like this. Agreed. So up to the reflection, both the paths were equal. After the reflection, if the two path lengths are equal, then I will have my Fermat's principle satisfied. So I can say move on to the next page. Okay, so therefore, paths after after let's call that line. Let's give this line some name AB. The paths after line AB must also be equal, right? According to Fermat's principle, line AB must be equal. Okay. Now, what are the two parts? What are the two parts? Let's talk about that also. So this guy is talking about this part. Okay, so let's talk about this. This is L1, and this is obviously going to be X, and this is going to be F. So L2 is X plus F, and L1 is nothing but uh, we can use Pythagoras theorem. Okay, so this is F. So let's call this point some D. Okay, so I can say L1 L1 would be equal to y square plus f minus x whole square to the root. See, that is what the length L1 is. So take a look at this triangle. Okay, take a look at this triangle. From here to here, to here to here, to here to here. In this triangle, you realize the base is f minus x, the height is y, so the length L1 would be this. Okay, now what about the length L2? The length L2 is the length of this path. 2 is the length of this blue path. And L2 is f plus x. Great. So therefore, according to Fermat's principle, these two lengths should be equal. So I can say that f plus x whole square should be equal to y square plus f minus x square. Great. Now what you have is something very interesting. Y square equals 4fx is the equation. Equation of mirror, which is in fact parabolic. So if you have this kind of mirror which follows this equation, y square equals 4fx, then all the light rays after reflection would get focused on the mirror itself or the focal point. Okay. So this kind of mirror can perfectly focus all the incident light. Okay. Therefore, parabolic mirror and perfectly focus all the incident light. So that is where I would like to conclude our discussion of curved mirrors. This is the final thing that I wanted to share about curved mirrors, that if you want to perfectly focus the incident light, then you must use a parabolic mirror. Okay. So with that, we will wrap up today's session. And before I leave you, let me remind you that if you haven't gotten your Uncapped subscriptions yet and applying to do so, you can do so by following these steps. You can go to the plus section of your app, select your goal as IIT JEE, click on that get subscription button. When redirected to the payment page, don't forget to use the code RDLive to get yourself a 10% off. And you can now choose from the plus subscription and the iconic subscription. The fees are as shown. Now you can also choose a no cost EMI option to break this payment into a lot of easy EMIs. Okay. And you can also now choose from the iconic subscription, which will take your ITJ preparation to the next level by allotting you personal coaches. Okay. Now these coaches will help you to guide you and mentor you personally, and will give you more individual attention. And along with those benefits, you can also join ITJ workshops to get expert guidelines from time to time, have a study planner, and have a regular test analysis sessions. Okay. So these benefits will definitely help you go ahead and in your JEE preparation. And now, if you're looking for a combination or a one-stop solution for all your preparations of class 11th and 12th studies, so be it your boards, be it your IIT exam, mains and advanced, so all of that is being brought to you in a combo subscription now. There are four kinds of combo subscriptions that you can offer. The first combo subscription offers you an iconic subscription for IIT and a plus subscription for 11th, 12th CBSE. This subscription starts at roughly 4,700 a month. The second combo offers you all three iconic subscriptions. This starts at 5,500 a month. Then you have a combo which offers you all plus subscriptions for IIT as well as your CBSE 11th and 12th. The subscription starts at 3,000 a month. And then you have a super combo where you have plus for IIT and iconic for your CBSE 11th and 12th. This combo starts at 3,900 a month. Okay, so you can choose from any of the combos that you feel comfortable with. Okay, so that is how you can go about this. Next, you can also test your understanding and your knowledge and the level of preparation. Check your standing amongst your peers, and if you do well, you can win yourself a really cool rewards and prizes by taking part in the next Unacademy Compact. So the next Unacademy Compact event is going to happen live on the 17th of January. You can enroll now using the code RDLive and do well and win yourself some really cool prizes, including year-long subscriptions of Unacademy Plus. Okay. Now, if you like today's video, if you found it interesting, then don't forget to press that like button, which a lot of you have already done. Now, the second thing is that make sure you are also sharing with all your friends and other people. So Unacademy is providing you this quality content completely free of cost on this channel. This is to help the students who cannot afford those subscriptions. So we believe that every student is entitled to quality education. So if students cannot get those subscriptions, they should still get a chance to get quality education through this channel, and it's your responsibility as a student to share it with fellow students who need it. Okay. If you're new to this channel, don't forget to subscribe and don't forget to press the bell icon. Now, PDF of all the slides used in today's lecture will be available for download for very soon. And those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link, so that you're not missing out on any of the notifications of lectures and sessions happening here on this channel. Now, this is where I wrap it up for today. And before I leave you, let me remind you one last time that this is my code RDLive. So if you're planning to get your Unacademy subscriptions, then you can use this code, get a 10% off on all your subscriptions. All right, and that is it. That is where I would like to wrap up today's discussion. In the next class, we will talk about refraction. Now that everything about mirrors is complete. Okay, now you guys don't forget to practice questions on mirrors. Okay, and next time we will talk about refraction, and I'll see you then. Till then, you guys keep studying hard, keep practicing hard, and take care of yourselves. Bye bye.